threes. So the answer lies on whether or not you could even read the table and understand the meaning of what that's, representing. And so some of you look at that and go, oh, I can do that. I just simply add the what? Frequencies. So I'm going to give you another formula. And the sample size is this capital sigma with a scripted F. You guys want to know what that is? Here is a formula that you guys want to remember. Okay? You guys want to remember. Anybody thinking of getting a tattoo? Thinking of getting a tattoo? No? Not going to get a tattoo? For extra credit? No. It's sort of funny. You ask people about the tattoos that they have, right? And you say, what does that mean? And sometimes, not always, sometimes they say, oh, I don't know. And it kind of baffles, it's sort of, you don't know what it means? No, it doesn't have any meaning to me. Just like the picture. All right. It's okay. It's okay if you like the picture. But then why wouldn't you ever get this tattoo? You don't know what it means? Good, I'll tell you. Oh, here you go. Here's what this is. Sorry, Eddie, you just blew everything. When I say get this tattoo, here's sort of what happens. When, if I give a test, and I will, and sometimes I do this to students, I give them a frequency table, and I say create a relative frequency table. And you want to know what they do? Instead of adding the frequencies, add the data. And I look at that, and it does something to me. It breaks my heart. Because now everything's wrong. All the answers are wrong. Just when really, what are they supposed to do? The frequencies. You're going to be sort of asked this sort of thing, throughout the course. So if you get it right now, you'll get it right throughout the course. And it's not that hard. This formula is not that hard. So when I say get this tattoo, of course I'm joking, but I really want you to tattoo it where? Your brain. Know first what it is by definition, and then be able to sort of remember it and use it. Okay? N is, the sample size is, you see this capital sigma? That means to what? To sum. That means to sum. But then what comes next when you say to sum, okay, I'll sum, which means add, right? I'll sum what? The frequencies. So this means to add, and what comes next is what you add. You're adding the frequencies. Okay, you okay with that? So if I go and I add these frequencies, right? Perform my addition now. 14 plus 4 is? 18 plus 0 is? 18 plus 2 is? 20. You see, it's still 20. Didn't we know that already? Okay. So we know the sample size. And very often, remember that formula, because, if you're given a frequency table, you don't have the original data, then you have to deduce it that way. Okay? You guys okay with that? Oh, this course is so easy. It's a crime. No? No? Oh, just add the frequencies. Okay. All right. We have to talk about some other thing that actually happens. Okay? This concept of what? Approximation. Or I'll say round off. Or estimation. Okay? This here is something in which students typically need to review how to approximate, right? How to estimate. And you guys know my first multimedia file that I created that you watch over the internet. That took me a gazillion hours to do. Pulling my hair out, crying, kicking, screaming the whole way. Fighting the world to get done. The first file I made, the first presentation I made, was partly about this statement here. And why do you think I did that? Because that is the first place where students start to have some trouble, is when you have to approximate. So I'm going to say this to you guys. I'll go through it sort of briefly. But if you're in that boat when you say, oh, I need to review how to approximate, okay, some will be in that boat, which is why I did that. What are you going to do? Go to the what? Go where? Go to the website and watch what? A review on approximation. Nice. You guys like that? Good. Thank you. All that fighting and all that crying and kicking and screaming was so that you guys can say thank you. Well, you don't have to say thank you, but just do well. Okay? You guys okay with that? So, let's see what happens here. Bless you. I'm going to say this. I'm going to ask you guys to approximate your answers to the nearest thousandths. Nearest thousandths. What does that mean? You got to have to know something about place value, right? Here's the 0. I'm sorry, here's 0 point. Or it doesn't have to be that, but okay. Here is the decimal value. This is your decimal. Okay, it's your decimal. You guys okay with that? That first position is what? The tenths. What comes next? The hundredths. Tenths. Hundredths. What comes next? Thousandths. Okay. This is where all your answers are going to have some value, I guess, right? In the thousandths. But how do you determine the value that belongs in that thousandths position? Do you guys know? You look to the right of that value. And I'll put an eyeball. Why am I going to put an eyeball there? Because that's the value that determines what this value will be. Okay, you guys okay with that? If the value here is a 0, 1, 2, 3, or 4, then what do you do with that value? Just leave it alone and chop off the rest. That's your answer, the 3 digits. But what if the value is a 5, 6, 7, 8, or 9? What do you do here? What do? You add 1 to that digit. And the answer here is going to be the answer you get. Okay? You guys okay with that? If you want to look at some more examples or some more detail, look at that file. That's why it's there. Oh, and do you get credit for doing it? Yes. Okay, let's compute the first relative frequency. What's the first calculation? Isn't the first frequency 14? 14